Okay, so question 7 says to show that this thing and this thing are equal, right? So the first bullet is through oh, okay, it's fine. Truth table, right? But unfortunately, I don't have that. So like, we're just gonna ignore that. I'm sure you guys can come up with the truth table on your own, so it's fine. Next thing is reasoning when each of them is false. And this one is without a truth table, right? So let's start off with this. Actually, feeling very lazy today. So, um, wow, iPad. All right, let me find the thing. So I've done this before starting, to be honest. It's fine. Okay, so the first thing we need to remember is that this, wait, this means implies, right? And then we have a truth table for that. And then this means and, I think, pretty sure, right? Okay, that means and then this upside down means or, right? The thing about and is that it's only true when both are true, or is only true, actually, or is the opposite. Only false if both are false, right? And then implies is only false when second variable is false, but first is true. I'm sorry for the bad handwriting, but you heard me, right? So we're supposed to show that when both of them are false, this is somehow gonna show that they're both equivalent, right? So like I said, look, laser. Like I said, this implies thing, which is you can see here and here, it's only false when the second variable is false, but the first one is true. By second variable, I just mean this. Wait, the thing on this side of the arrow, right? So here R has to be false, and here R or not Q has to be false. I should probably add that. Not is not, right? So how in what scenarios would those be false, right? If the whole thing will be false when it's gonna be true implies false, right? Same thing is gonna be here. It's gonna be true implies false. That's when the whole thing is gonna be false, right? Okay, so P and Q has to be true, right? And then P and Q, right? Like we said about and is only true when both of them are true. So that means P is true, Q is true, right? We agree on that. And then now we took care of this part, right? Now, if we have to have a false implication, that means that R has to be false, right? Because true implies false is a big false. So there you go. So for these, remember P is true, Q is true, R has to be false. Cool? Cool. For this one, P has to be true because P is on this side of the arrow and it's supposed to be true implies false. So that's why P is true. Cool? Cool. Now, R or not Q has to be true, right? So either of them have to be true. So now, wait. So this whole thing has to be true, and it's a or. So either one of them has to be true. Either this has to be true or this has to be true, right? And there's a not here. So if there's a not here, if Q is false, not false is true, right? And then R can be false, and then if Q is false, you get that. But the aim of the game is to like match this with the other thing, right? So let's see. Oh wait. Okay, so it's gonna be true implies false, right? So I messed it up. Um, it shouldn't be true. It should rather be false. So this whole thing has to be false. So now it makes sense. In what way would something in OR has to be false, right? Like we said, OR can only be false if both are false, right? So both R and this thing have to be false. So that means R has to be false, right? And then not Q has to be false. Not Q has to be false. That means Q has to be true, because not true is equal to false. That's why Q has to be true, right? Now, now it's going to be true implies false, which is a big false. Cool? Cool. Now, if you notice the values, P, we said P has to be true here, and then we said R has to be false, and then we said Q has to be true. So now, we understand that. Now, if you compare the values, right? For both, P is true. Wait, for R, both have a false R. Oh my god, for Q, both of them are true as well. So you have true, false, true, and in both scenarios, both this and this both give you a big false, right? So, since the same values for P are Q, true, false, true, give the same outcome, false, the statements are equivalent. That's basically what he means when he says reason when each of them is false. He means each of these when each of them are false. The realization he wanted for us to conclude is that for both of them P is true, for both of them R is false, for both of them Q is true. If you have the same value for each of the variables and you put them into two separate equations and the outcome is the same, that basically means that both statements are equivalent.